Okay, so that's what I'm going to go through right now. The idea here is that Douglas Hofstadter is interested in one primary question, and that question is, how does a self come out of things which have no selves? How is it that all these carbon atoms and molecules and proteins which make us up in the physical universe, how do they go from being meaningless to developing into an entity which can refer to itself? Like right now I'm saying, I think this, I think you like this. I'm meeting all of you as individuals. Each one of you claim to have a self. You might remember Descartes' famous quote, I think, therefore I am. So it seems like the I, when I say the I mean the things we call ourselves, as a real existent thing. But it's a complex question. How do we get I's out of non-I's? And that's kind of going to be the goal over here. So I'm just going to call it I. But how do you get to an I? You get to an I by having a bunch of meaningless primitives, things like atoms, proteins, molecules, I should say, if I want to, etc. Like this is what you're made up of. But none of these things mean anything. None of these things have I's or selves. But you do. So what's the relationship here? Douglas Hofstadter, he wrote this book back in the 70s when he was doing graduate school in physics. And this was after him doing math undergrad at Stanford. He believed that he saw the answer when he was playing around with mathematics and the very formal systems we play with. Like when we write down things like 2 + 2 = 4, these are just symbols. And as we go through today, I'll show you completely equivalent ways of doing addition, which will look like this. And these are just logical primitives. And if you've seen any set theory, and don't feel scared if you haven't seen any of these symbols, but like there exists an X for every. We give these interpretations, but the idea is that mathematics can be reduced to a bunch of meaningless operations, just symbol shunting. But what's interesting is that within mathematics, there exists an equivalent to self-reference. This is a bunch of atoms and proteins referring to itself, calling itself an I. What happens here, and this is going to be kind of underneath the name of Gödel. Is we're going to get to some incompleteness theorems. We're going to get to some statements which in mathematics refer to themselves. And the question of how this happens, we understand this rigorously. Mathematicians have worked out how do we go from meaningless symbols to something which refers to itself and which has meaning. The claim then is that these two systems are equivalent. And this is really the profound idea. I'm going to draw this symbol, and I'm going to use a term called isomorphism. And isomorphism is basically an equals to, and equals in a different sense. But the idea here is, in many ways, we can link atoms and proteins to kind of logical, symbolic primitives in mathematics, and we understand how we get self-reference in mathematics. So maybe we can use this to understand how we get I's, how self comes out of non-self. This is a really tall order, but we're going to try to do it, and that's what this book attempts to do.